looking at some sample timings for what we did. I ran these tests in the environment when I wasn't recording things and having a webcast going and using the laptop for all sorts of other stuff. And here's the timing I saw just for disk-based row store indexes first. By just providing non-clustered indexes, I am able to make this faster, but it's going from like 26, 27 second duration to a 23 second duration. Because this is essentially just pre-sorting the data first, but it's still got a lot of work to do, and that window spool operator is still just a lot slower. With the non-clustered column store, and I did have to, do some tweak. I had to get rid of that row store index to get it to use this. It was the optimizer was deciding to still use the row store index while it was still there. But when it actually does use the column store and we get the new window aggregate operator, I could get it down to about 7 seconds. So a huge improvement, most of which is due to the window aggregate operator, not due to some magic of how the column store index is stored in this case. Now, in some cases, the magic of column store indexes itself will just vastly speed certain things up. But in this case, it was really that new operator. But the fastest performance times I can get are actually when I can get SQL Server to pre-sort the data in a row store index and get it to use that index, which in this case, I had to use a hint to get the optimizer to use it. And then I also trick it into giving me that new batch mode window aggregate operator. But I have to hack that in by, I created a non-clustered column store index with an impossible filter. So to get this fastest time of 2.8 seconds, I had to create a hacked index that the behavior of which might be not stable, right? Because this is not a documented use of this by Microsoft. And then I had to add a hint as well. But if that's okay to do in my environment, I may be able to get the best performance because the data is pre-sorted in the row store index just for this windowing function. And then I'm using the fast operator. When we're talking about indexing for windowing functions in general, basic concepts, that acronym of POC that Itzik Ben-Ghan gave, look at the partition by, look at the order by, and then look for covering columns as well. That number 3, name count, we used as an included column. And essentially, when I created the index view, I was indexing by these things as well. And that makes sense because when we partition by and order by, we're talking about what are the sets that we need to group or order. Those are key columns. Covering the name count prevents it from having to go back and look up rows in the base index. If you're tuning windowing functions and you're in SQL Server 2016 and higher, what I would really look at is, can I get that new window aggregate operator, which is a batch mode operator? I may or may not want to actually use column store for real, depending on how the table is used and, depending on the insert update rate of data to the table, right? Even if you're using column store for real, don't just assume you're always going to get the new window aggregate operator. We saw a case, right, where I had that column store index on the table. It was fully populated. It was fully usable. And SQL Server was like, I'll go use the row store index instead. And you'll get your row mode window spool operator, right? So verify in your execution plans, am I actually getting the window aggregate operator? If you're not using column store and you feel lucky, maybe you just want to hack it in like we saw. All right, folks, thanks so much for joining me